In this lesson, we're going to look at the cosine law. We use the cosine law when we want to calculate side lengths or angles of oblique triangles, in other words, ones that don't have 90 degrees, not right triangles, and when you don't know an angle across from a side. Because remember, if you do know an angle across from a side in this situation, you're going to use the sine law. Cosine law, basically, there's two situations that we use that. If we don't know an angle across from a side, we must have an angle in between two sides. Let's see if I can draw a little sketch just to represent this. So squeeze it in here, see what happens. All right, so if I know, say I know this side and this angle, so an angle between two sides, we call that side angle side, SAS for short. Or if I know all three sides, then I can use the cosine law to find the missing angle, a missing angle. So I call that side, side, side for all three sides known. Notice in neither one of those situations do I know an angle that's across from a side, the pairs like we do in sine law. So if I want to find a side length, we'd use this one for when we have SAS. When we have side angle side, then I use this version of the formula here. A squared equals B squared plus C squared minus 2BC cos A. That's assuming that we labeled our triangle ABC. And I guess I've already said it over here, side angle side, but that's all right. We can rewrite this formula to solve for any side. So this one's just arranged so that it's A is isolated, but say I wanted to isolate B, then I'd say B squared equals A squared plus C squared minus 2AC cos B. So you'll notice how the letters, I've swapped them around in different places, but I'm using the exact same letters. And if the triangle involves different letters, say the triangle was DEF for the corners, then maybe F squared would equal D squared plus E squared, the other two sides, minus 2 times D times E times the cos of big angle F. So it's easy enough to change this formula around. It doesn't matter what angle we're looking for or what we call those angles. Sometimes I don't even worry about putting letters on them at all. I just plug numbers in the appropriate places. Find the measure of the unknown side to the nearest tenth of a unit. So in this case, the unknown side is B. And I know this side, this angle, and this side. So I know side angle side. So I can find out what B is. I can say B squared equals, if I want to be picky, then this is technically side A and this is technically side C because the sides are across from the angles. So I could put the 52 as A first, so 52 squared plus C squared, which is 36 squared, minus 2 times A, which is 52 again, times C, which is 36, times the cosine of the angle. We only have one angle, so it's easy to know what angle I put in here. I recommend typing it all out at once because my calculator can sort out the order of operations for me if I do that. If you choose not to do that, that's fine, but what you have to understand is that order of operations does have to be followed. So you need to multiply, in this part here, you need to multiply 2 times 52 times 36 times cos 42 before you subtract. In other words, what I sometimes see is things like this. This will just be some random numbers I make up, nothing to do with this actual question. But they'll get to a point where they'll have like maybe 100 plus 36 minus 57 cos, I don't know, 92, whatever. they should have multiplied all of this out before they subtract, but what they do instead is they think of this cos whatever as a separate number, and then they just add these up, and they go, 100 plus 36 minus 57. Okay, that's 100, that's what, 79, 69. What is that? Let's see, 21, 79, I guess. They write this is like 79 cos 92. That's wrong. That's breaking order of operations. Don't do it. I'm going to erase it. So now that I've shown you what not to do, type it all in at once. So if you want to type this in stages, just make sure you do that whole part that I've underlined in red before you subtract. But what's even better is to just type it all in your calculator at once. So 52 squared plus 36 squared minus 2 times 52 times 36 times cos, and it was 42. 42. My calculator does it all for me in one shot, 1217.6. And then the last step is to take the square root of each side. Taking the square root of the left gives me just b, and then I have the square root of whatever my answer was. Usually, most calculators have the option of then taking your previous answer, which is still in the calculator, and hitting and just typing it in again. So I didn't have to retype in the 1217, as you can see on my calculator. I just grabbed it from above, and I got 34.9 if I go to one decimal place, which is a tenth of a unit. 34.9. Units are feet because that is what was given for the other sides, and that's my answer. The last thing I would do is just check, does my answer make sense? So in other words, say you forgot to take the square root back up here. If you thought the final answer was 1217, you probably wouldn't make that mistake if you compared it to the other side lengths. It's not likely that you're going to have one side length be 36 and the other be 52 and the other be 1217. That should raise a red flag, and then you might remember, oh yeah, I still have to take the square root. As pointed out earlier, we can also use the cosine law to find an unknown angle if we know all three sides. Here's the formula. So again, this is one that can be rearranged or repurposed for whatever angle we're trying to find. And it could be other letters again other than A, B, C. And we use this version if we want side, angle, side. And this version here is really just the same as the one up at the top of the page here. If I were to take this top of the page version, a squared equals b squared plus c squared minus 2bc, got carried away there, 2bc cos A, and try to isolate cos A, I can do that. I could subtract b squared and c squared from each side, and I end up with a squared minus b squared minus c squared equals negative 2bc cos A. And then I could divide each side by negative 2bc. And what I'm left with on the right is just the cos A. And what I can do is I can simplify the signs a little bit. If I divide the top and the bottom by this negative, so if I leave the 2bc on the bottom but divide everything by the negative, what I'll get is negative a plus negative a squared plus b squared plus c squared over 2bc. And then it's just a simple thing to flip the side, so I'll bring the cos A over to this side. And to rearrange a little bit, if I just pop this negative number at the end, then I've got the formula exactly the way we're used to it. B squared plus c squared minus a squared over 2bc. So there's the formula. That's how you can get it from the original formula. And it's another easy one to remember. Here's how I usually describe it. Whatever angle I'm looking for, in this case it's A, that side length, the side across from it, only shows up once. That shows up in the numerator, and that's the side length that you square and then subtract. You notice B and C are squared and added together, and B and C also show up in the denominator, but the side across from the angle, whatever that side is, could be A, B, C, whatever, is always the one that you're subtracting at the end of the numerator. So just a good way to remember the formula. And again, what if I was to rewrite it for a different side? I wanted to find angle C, then I could say cos C equals A squared plus B squared minus C squared. How did I know that so quickly? Well, again, because C was the side angle I'm trying to find, so I subtract C from the numerator. And I also know that the denominator will be 2 times the other two sides, A and B in this case. And if I wanted to use different letters, say PQR, and I wanted to find angle P, then it would be Q squared plus R squared minus P squared over 2QR. I'm just following the pattern. Find the measure of all angles to the nearest degree. So this is a side, side, side situation. What angle do I start with? That's the first question. The answer is it doesn't matter. So maybe I'll start with L just because that's the first letter alphabetically that I see there. So I would set it up as cos L. That's the angle here that I'm trying to find. And then as far as the sides go, it's going to be, this is little l, this is little n, and this is little m. So remember, I am going to have the side L come at the end of the numerator, and that's a subtract. So the other two, I'd have 14 squared minus 12 squared, plus 12 squared minus 10 squared, that's my L, over 2 times 14 times 12. Again, 14 and 12 are my m and n. Again, I can type this all in at once. So I'm going to use brackets here because of the way my calculator works. 14 squared plus 12 squared minus 10 squared divided by 2 times 14 times 12. Now again, this is kind of an unusual calculator, the way it presents things. You have to learn your own calculator for what order to put the buttons in and whether you need brackets or not. What I'd actually recommend you do is do this exact example along with me, rewind it if necessary, and type it in your calculator until you get the same answer as me of 0.714285. Just making sure I wrote that down right. Yeah, except it should be 8.6 if I'm rounding. Anyway, and then, as you should know, as we all know, when we're getting angles, we have to do one extra step. I have to take the inverse cos of each side. So angle L is actually going to be cos with the -1 of this decimal. Again, I've still got the decimal on my calculator, so I'll just use that. I'll just go in the next line down, I'll go function cos -1, answer, and it turns out to be 44.4 degrees. But it says to round to the nearest degree, so let's call it 44 degrees. That's one of my sides. Now at this point, now that I know this is 44 degrees, now I've got options. I could use the sine law, now that I know this side and angle across from each other, or I could just continue with the cosine law. Since this is a cosine law question lesson, I'm going to do cosine law again. So I will find m this time. So m, cos m, is going to equal, now things change again. So this is the side that has to be subtracted at the end, isn't it? So it's going to be 10 squared plus 12 squared minus 14 squared over 2 times 10 times 12. So exact same numbers, but in different places, different arrangements. That's going to give me a different answer overall. I'm just going to change these ones rather than retyping it completely. So 10, 12, 14, and change this to a 10. I think that is what I want. And so I got 0.2, which means that angle M is going to be the inverse cos of that. And since I changed it on my calculator, I've got the answer there already. That's 78.4 degrees again, if I'm rounding to the nearest degree. So I guess 70 down to 78. I just rounded down to 78 degrees. And now that I know two angles, I can get my third one. I never have to go through this 3 times. I can just get my last angle by remembering that all triangles add up to 180 degrees. I can subtract the 2 angles I've already got. And 78 and 44 is 82, 122. So I guess that should be 58 degrees for angle N. Okay, and the last example, example 3. Determine EF to the nearest tenth. So EF means the side length between E and F. I'm just to find that. And I can see there's a couple other triangles going on here. And probably, it's just glancing at it to see which way I want to start. I guess, let's start by using some angle rules back from grade 9. So first of all, we know that a straight line makes 180 degrees. So I can tell that this has to be 60 degrees. I know that this plus 60 plus 45 has to add up to 180. Again, this triangle here, this is a triangle, has to add to 180. So this angle up at the top has to be 75 degrees. 75 plus 45 equals 80, plus 60 equals 180. So there's all my angles within that smaller triangle on the right. Since I know that side length, then, or those angles, I guess I could find this one here. Let's call this one over here X. Okay, so I'm going to use this angle and this side length along with this angle and this side length. And what I can then use is the sine law to help me figure out what X is. And so sine law tells me that X over sine 60 is equal to 14 over sine 75. And when I'm solving for X in these equivalent fractions, generally what's going to happen is whatever's on the denominator under the variable is going to end up in the numerator of the other fraction. So it's going to be 14 times sine 60 over sine 75. That's just how it always ends up. So I just do that without worrying too much about the math behind it, since I know that it's good math. So 14 times sine 60 times sine 60 divided by sine, can't quite see it, sine 75, divided by sine 75. And so I got 12.55. I'm going to carry 2 decimal places, at least for now, because I don't want to round too soon. So this is 12.55. And now I can, if I take these two guys together, they add up. 8 plus 14 adds up to 22 units, whatever that is. And this side over here, I already know, is 12.5. I know this angle in between, so I've got side, angle, side going on, and I can use my cosine law for that. So let's just call this y because it's easier to work with one variable rather than call it EF. So I know that y squared is going to equal 12.55 squared plus 14 squared minus 2 times 12.55 times 14 times the cos of 45 degrees. And again, this is a case where I would put it all in my calculator at once. Sorry, it was 22, wasn't it? 22, 20. Oh, where did 14 come from? Oh, I see. I made a mistake. I was focused on that 14 that I highlighted in blue, but I remembered 22, so these should be 22 here and 22 here. So 22 squared minus 2 times 12.55 times 22 times the cosine of 45 degrees. And again, my calculator does it all for me at once. I got 251, I guess 0.0. Let's just call it 251. If I take the square root of each side, then whatever the square root of the 251 is will be my side length for EF. $15.8. So there you have it. Know the formulas for cosine law. Just get familiar with putting your values in the correct place, and definitely following order of operations when you do cosine law.